Okay, so it's really important with Le Chatelier's principle that you understand that there's a reaction to any stress on the system. So reactions love to be at equilibrium. And if you mess with equilibrium, the reactions do everything it can to get back to equilibrium. So what we're going to do right now is we're going to mess around and add things that are involved in this reaction. Now, it's really important. If I add something that's not part of this equilibrium in here, so if I'm like, hey, I'm going to add some helium into this, is helium going to make any difference in this equation? Absolutely not, because there's no helium in there. But in the first question here, they say we're adding in some H2O. So what that means is we are increasing the H2O. Now, if we increase the H2O, that means that when we compare our products to our reactants, we have more products than we should at equilibrium. So whenever we do this, if we increase the H2O, the reaction is going to want to shift away to balance off that change. So if we're thinking that way and we add H2O, which direction is the reaction going to shift? It's going to shift back in this direction, so it's going to shift to the left, right? Now, then we're going to ask what's going to happen to the pressure of C2H2 and the pressure of O2. So just think of it this way. If I go in this direction, won't I be creating more of this and more of this? And if I create more gas particles, won't the pressure of this go up? And won't the pressure of this also go up? So if I'm answering this question all the way out, I'm going to go, well, this is going to shift to the left. And then what's going to happen to the pressure of this? It's going to go up. And what's that going to happen to this pressure? It's also going to go up. Now let's go the opposite way on this. And we're going to be like, all right, what if we were to remove C2H2? Now, what we're doing is we're removing a product. That means we're messing with the amount of products, lowering what they should be at equilibrium. So if we remove this, the reaction is going to move this direction to compensate for what we've just done. So if that's the case, we know that the reaction is going to shift to counteract that. So it's going to shift to the left again. Now, when it shifts to the left, it's going to have some impact on our products and our reactants. We know that if it goes this direction, we're going to lose stuff on this side and we're going to gain stuff on this side. Now, the question is here, what happens to our O2? So if we're moving in this direction, that means that our O2 is going to go up, and that means our pressure for O2 is going to go up. If we look at the reaction going this direction again, what's happening to CO2? Well, we're losing CO2, so the CO2 pressure is going to go down. And let me make sure that I'm Xing this as well. Hopefully this has been helpful. Have a great day.